Good morning, my dear students of first secondary. Today we are going to talk about multiplying of two matrices, and this is lesson 3 in algebra, second term. Let's go. First secondary algebra, unit 1, lesson 3, multiplying of two matrices, prepared by Mr. George Milad. Multiplying of two matrices. If A is a matrix of order M times L, that means that M is the number of rows and L is the number of columns. B is a matrix of order R times N. That means that R is the number of rows and N the number of columns. Okay, so M here is the number of rows, L is the number of columns, and here R is the number of rows and N is the number of columns. Then their product C equals A multiplied B will be defined if and only if L equals R. This is an important condition. We can multiply two matrices if L equals R, where L is the number of columns of the matrix A and R is the number of rows of the matrix B. And the matrix C, which is the product of multiplying A times B, will be of order M times N. Okay, for example, here A is a matrix of order A M times L, and B is a matrix of order R times N. Then the resultant matrix A times B will be of order M times N. Okay, so L and R must be equal. So if they are equal, so we can find the multiplication of the two matrices A and B, and the resultant matrix will be of order M times N. Okay, let's go to an example to explain the lesson. Example 1, if AB, find AB or A times B if possible in each of the following. Here the matrix A is of order 3. Here the matrix A, you can see that the matrix A formed from 3 rows and 2 columns, so it is of order 3 times 2. And the matrix B is of order 2 times 2. Here you can see the number of columns of the first matrix equals the number of rows in the second matrix. Here we have 2 columns, and in matrix B we have 2 rows. So we can multiply the two matrices, and the resultant matrix will be of order 3, okay, times 3 times 2. The resultant matrix will be of order 3 times 2. Okay. How can we find the product of the two matrices? Let's go to find the product. Here first we are going to multiply the first row times the first column. Okay, let's do it together. So it will be, here we will multiply the first element, 2 times -1, it will be equals 2. And we will multiply 1 times 0, and it will be equal 0, so we'll write 2 plus 0. Okay, again we will multiply the first row by the second column. Okay, first element times first element, 2 times 2 equals 4, 1 times -3 equals -3. Okay, let's do it again for the second row. Now we are going to multiply the second row by the first column. The second row by the first column, 3 times -1, it will be -3. And -1 times 0, it will be equals to 0. And we are going to multiply the second row by the second column. 3 times 2 equals 6. Negative 1 times negative 3, it will be positive 3. And last, we will multiply the third row by the first column. 0 times negative 1, it will be equals to 0. 4 multiplied by 0, it will be equals to 0. And the third row by the second column, 0 times 2, it will be equals to 0. 4 times negative 3 equals negative 12. So the resultant matrix will be equals 2 plus 0, 2. 4 minus 3 equals 1. Negative 3 plus 0, negative 3. 6 plus 3 equals 9. 0 plus 0, 0. 0 minus 12, it will be equals to negative 12. And you can see that, as we said before, this matrix of order 3 times 2 and the other matrix of order 2 times 2. So here the number of columns of the first matrix equals the number of rows of the second matrix, and the resultant matrix, it will be of order 3 times 2. Here we have 3 columns and 2 rows, so it will be of order 3 times 2. Okay? Let's go to another example. If A is a matrix 1, 2, 3, 1, 0, negative 2. This matrix of order, you can see 2 rows and 3 columns. And the second matrix B is of order. Here we have 2 rows and 3 columns. Okay? As you can see here, the number of columns is not equal the number of rows. So A times B or AB is impossible to find. A times B is impossible to find. Why? Because the number of columns of the first matrix is not equals to the number of rows in the second matrix. Okay? Let's go to another example. Here we want to find the multiplying of the matrix A times the matrix B. Here the first matrix is of order. This is a row matrix 1 times 3, 1 row and 3 columns. And here we have a column matrix of order 3 times 1. Here the number of columns equals the number of rows, so we can multiply the 2 matrices, and the resultant matrix will be of order 1 times 1. How can we find the product of A times B? It will be equals to, here it will be only one element, so the resultant matrix here is of order 1 times 1. Okay, 1 row and 1 column, 1 row and 1 A column. Let's do it together. 2 times negative 2, it will be equals to negative 4. Negative 1 times 1, here it will be negative 1. 3 times 4, it will be plus 12. Then we add all the elements together. Negative 4 minus 1, negative 5, negative 5 plus 12, it will be equals to 7. And this is a matrix of order 1 times 1. Okay, so easy. Now we can multiply any 2 matrices. Let's go to another example. Example 2. If A is a matrix of order, here A is a matrix of order. Here we have 2 rows and 3 columns. And B is a matrix of order also. Here we have 2 rows and 3 columns. Okay? He asked you to find the multiplying or the product of B of A times B transpose if possible. Here we want to find A times B transpose if possible. Okay, let's solve it together. Solution. A multiplied B transpose. First we are going to write the matrix A, 1, 2 and 3, 1, 0, negative 2. Okay, multiplied by B transpose. Here B transpose, first we have to find B transpose. B transpose, we will get it by changing or replacing the rows by columns. So it will be 1, 5, 3, and replace the second row to be the second column, negative 1 to negative 4. Okay? Now check it. The first matrix is of order 2 times 3, and the second matrix is of order 3 times 2. Okay? Here, the number of columns of the first matrix equals the number of rows of the second matrix, so we can multiply A and B, and the resultant matrix will be of order 2 times 2. The resultant matrix will be of order 2 times 2. Okay? Let's do it together. A, B transpose. It will be equals to. First, we are going to multiply the first row by the first column. First row by first column. 1, the first element times the first element. 1 times 1 equals 1. The second times second. 2 times 5, it will be equals 10. 3 times 3, it will be equals to 9. Okay? And we are going to multiply the first row by the second column. 1 times negative 1, it will be equals to negative 1. 2 times 2, 4. And 3 times negative 4, it will be negative 12. Multiply the second row. Multiply the second row by the first column. 1 times 1 equals 1. 0 times 5, it will be equals to 0. Negative 2 times negative 3, it will be equals to negative 6. Multiply the second row by the second column. 1 times 1, it will be negative 1. 0 times 2, it will be equals to 0. Negative 2 times negative 4, it will be equals to 8. Okay? Last step, add 1 plus 9, 10. 10 plus 10, it will be 20. Okay? Negative 1 plus 4 equals 3. 3 minus 12, it will be equals to negative 9. 1 minus 6, negative 5. Negative 1 plus 8, it will be equals to 7. Okay? So the resultant matrix is of order, here you can find, is of order 2 times 2, as we said in the first example. Okay? Okay, let's go to another example. Here, a very important example. If A is a matrix of order negative 1, 0, 2, 3, then prove that A power of 2 minus 2A minus 3I equal 0. This example is very, very important. Okay? Solution. Solution. First, we want to find A power of 2, the matrix A power of 2. Here, the matrix A power of 2, it is not equals to find the matrix negative 1, 2, 0, 3, and to find the square of each number. This is completely wrong. Okay? So, what we mean by A power of 2? Here, A power of 2 means multiplying the matrix A times the matrix A. Okay? So, now we are going to find A power of 2, which is equals to negative 1, 2, 0, 3. Okay? Multiplied by the other matrix, negative 1, 2, 0, 3. Okay? So, A power of 2 here means to multiply A times itself. Okay? Multiplied A times itself. Okay? Okay. Here we want to find the multiplying of the two matrices. How can we do it? First, we have to multiply the first row by the first column. Okay? Negative 1 times negative 1, it will be equals to 1. And 2 times 0, it will be equals to 0. Negative 1 times 2, it will be equals to negative 2. 2 times 3, it will be equals to 6. And we will multiply the second row by the first column. 0 times negative 1, it will be equals to 0. 3 multiplied by 0, it will be equals to 0. Here we are going to multiply the second row by the second column. 0 times 2, it will be equals to 2, 0. 3 times 3, it will be equals to 9. Okay? Add 1 plus 0, it will be equals to 1. Negative 2 plus 6, it will be equals to 4. Here 0 plus 0, it will be equals to 0. 0 plus 9, it will be equals to 9. Okay? Here I want to erase this plus sign. Okay? It will be equals to 4. Okay? Let's continue. Now we are going to find minus 2i. So now we have a power of 2 minus 2 multiplied by the matrix A minus 3i. So what is the matrix 3i? We all know that I is a matrix of order 2 times 2, or I is a matrix of order 3 times 3. And the identity matrix is a matrix, all its elements equal 0 except the elements of the main diagonal. So it will be 1, 0 and 0, 1. And if I is a matrix of order 3 times 3, it will be 1, 0, 0, 0, 1, 0, and the last row will be 0, 0, 1. Okay? Now we are going to find a power of 2 minus 2i minus a power of 2 minus 2a minus 3i minus 3i. Okay? Minus 3i. Okay, now we get a power of 2. A power of 2 equals 1, 0, 4 and 9 minus 2a. That is to say that we are going to multiply the matrix A, all the element of the matrix A, by negative 2. Okay, multiply all the element of the matrix A by negative 2. Negative 2 times negative 1, it will be equals to 2. Negative 2 times negative 2, negative 2 times 2, it will be equals to negative 4. Negative 2 times 0, it will be equals to 0. Negative 2 multiplied by 3, it will be equals to negative 6. Minus 3i, 3 multiplied by the identity matrix. Of course, here I is a matrix of order 2 times 2. So we will write 1, 0, 0, 1. Okay? Now we are going to find, let's erase this first. Okay? And we will write this matrix here. Minus 3 multiplied by the identity matrix 1, 0, 0, 1. Okay? And now we want to find the sum of these matrices. We are going to find the sum of these matrices. Okay? Let's go. And this will be equals to 1. Here we are going to add 1 plus 2 equals 3. 3 minus 3, it will be equals to 0. 4 minus 4, 0. Negative 3 times 0, it will be also 0. So the result here is also 0. 0 plus 0, 0. Negative 3 times 0, it will be also to 0. And 9 minus 6, 9 minus 6 equals 3. 3 minus 3, it will be equals to 0. If you want me to multiply this matrix for you, it will be, here we will put a positive sign. Negative 3 times 1, it will be negative 3. Negative 3 times 0 will be 0. Negative 3 times 0, it will be 0. Negative 3 times 1, it will be negative 3. add the three matrices together, the result will be the matrix 0, 0, 0, 0, which is the 0 matrix, or we can denote it by the letter O. Okay, let's go to another example. Example 4, if A is a matrix whose elements are 2, negative 1, 4, 3, 5, 7, B is the matrix whose elements are 6, 1, negative 3, 9, 2, negative 8. Here he wants you to check that AB for all transpose equals B transpose times A transpose. Here he wants you to check that is to say that he wants you to prove that AB for all transpose equals B transpose times A transpose. Okay? First we are going to find AB for all transpose. So now solution, we are going to find AB for all transpose. How can we find AB for all transpose? First we are going to find A times B. Multiply here the first row by the first column. 2 times 6 equals 12. Negative 1 times negative 3, it will be positive 3. 4 times 2 equals 8. Multiply the first row by the second column. 2 times 1, it will be equals to 2. Negative 1 times 9, negative 9. And the last one will be 4 times negative 8, it will be equals to negative 32. Okay, let's erase this bracket. Okay, now we are going to multiply the second row by the first column. 3 times 6, it will be equals to 18. 5 times negative 3, it will be equals to negative 15. 7 times 2, it will be equals to 14. Okay? Okay. The second row by the second column. 3 times 1, it will be equals to 3. 5 times 9, it will be equals to 45. And 7 times negative 8, it will be equals to negative 56. Okay? Add these elements together. Okay, now we want to add these elements together. It will be here 12 plus 3, it will be equals to 15. 15 plus 8, it will be equals to 23. 2 minus 9, it will be equals to negative 7. Negative 7 and negative 32, it will be equals to negative 39. Again, 2 minus 9, it will be equals to negative 7. Negative 7, negative 32, it will be equals to negative 39. 18 minus 15 equals 3. 3 plus 14, it will be equals to 17. Here, 3 plus 45, it will be 48. 48 minus 8, it will be equals to 40. Okay? But here we want to find AB for all transpose. So we will find the transpose of the matrix AB. So here it will be 23, negative 39, 17, and 40. Okay? This is the result of multiplying A times B for all transpose. Now we are going to find B transpose multiplied by A transpose. B transpose means here we have 6, 1 as a column, negative 3 and 9 as a column, and the third row will be the third column, so it will be 2 and minus 8. Multiplied by A transpose. A transpose, it will be 2, negative 1, 4, and 3, 5, 7. Okay, let's multiply it together. Here is the first row multiplied by the first column. 6 times 2, it will be equals to 12. Negative 3 times negative 1, positive 3. 2 times 4, it will be equals to 8. Okay? First row times second column. 6 times 3, it will be equals to 18. Negative 3 times 5 equals negative 15, and 2 times 7 equals 40. 1 times 2, it will be equals to 2. 9 times negative 1, it will be equals to negative 9. Negative 8 times 4, it will be equals to negative 32. And the last one, here, 1 times 3, it will be equals to 3. 9 times 5, it will be equals to 45. And negative 8 multiplied by 7, it will be equals to negative 56. Okay, as you can see that the two matrices are equals by adding here 12 plus 3, 12 plus 3, 15, 15 plus 8, it will be equals to 23, and negative here will be negative 39. By adding, it will be equals to 17, and the last one, it will be 40. Okay, so here from 1 or 2, we can find that the two matrices are equal. So now we can take it as a rule that if we distribute the transpose on the multiplying, this is equals to B transpose, A multiplied B for all transpose. This is equals to B transpose multiplied by A transpose. Okay, thank you so much. Until we meet again next time, goodbye and good luck.